In our next question, we are given with if ax square plus bx plus c equals 0 has two real roots alpha and beta such that alpha is less than minus 1 and beta is greater than 1, then we need to show that 1 plus c by a plus modulus of b by a is less than 0. Now this is an interesting problem because it is based on the location of roots concept. We see that our one of the root is given that is less than a given quantity and our other root is greater than the given quantity. So if we make the curve ax square plus bx plus c equals 0, considering a to be greater than 0, if this is alpha, this is beta, we can clearly say that minus 1 and 1 lies in between the two roots of the equation, since alpha is less than minus 1 and beta is greater than 1. So we know that the value of f of 1 minus 1 and the value of f of 1, these two values, they are definitely less than 0. If f of x is equal to ax square plus bx plus c, then we can very clearly see that the value of f of minus 1 is also less than 0 and f of 1 is also less than 0. So taking x equals minus 1, we get f of minus 1 equals a minus b plus c is less than 0. Now since we took a as positive, so dividing the whole equation by a, we get 1 minus b by a plus c by a to be less than 0. This is the first equation. And also we can clearly see the value of f of 1 is equal to 1 plus b a plus b plus c, which is again less than 0. Now since a is positive, so dividing the whole equation by a again, we get 1 plus b by a plus c by a is again less than 0. This is our second equation. This was our first equation. Clearly from the first and second equation, we can comment that 1 plus modulus of b by a plus c by a is less than 0, which was the desired result we needed to prove. So this was an important question since it was based on the location of roots concept.